Hello everyone. Welcome to the video lecture. So this is first of the two video lectures I'm going to post on Friday. And for this lecture, we will still keep working on hydrostatic forces on plane surfaces. This one is a little bit more trickier than the previous one, than the one we solved in the classroom. And the reason is torque was included in the consideration. The force diagram is much more complicated, which is shown here. Yeah, you need to consider the weight of the weight of your gate, and there is a stopper here. Have another force bx, and also you have it's fixed at the A point. So I will read for you first. I will read the problem first, and then we will solve it together step by step. And at the place you possibly want to pause and then work on by yourself, I will remind you. So it talks about rectangular gate of a dimension of 1 meter by 4 meter is held in place by a stop block at B. So this is the gate. And we can see this direction is 1 meter, which means its other direction is longer. So here is 4 meter, and this part is 1 meter here. So this is the shape of the gate, and it's secured at point A here. This is A, and there is a stopper at B. These blocks exert a horizontal force of 40 kilonewtons and a vertical force of 0 newtons. So B is pushing the door to this direction, right? And it's 40 kilonewtons. The gate is pinned connected at A, and this is your pinpoint. We have this is the A, your pinpoint, and the weight of the gate is 2 kilometer. Find the depth H of the water. Okay, this is they want you to calculate H. Why H matters? We can try to do the force analysis on the left hand side here. So theoretically, both the weight, you see it's this direction, right? And it's trying to, the weight is trying to rotate this gate counterclockwise, the same as the stopper B. They all try to rotate the gate counterclockwise, but your hydrostatic force F is trying to rotate your gate clockwise. So theoretically, all these forces should balance around A. This A is the fixed point. So then it's a torque balance, right? And torque equals F multiplied by R. T equals F multiplied by R, right? So let's first take a look at the. So how about you pause here and take around 5 to 10 minutes to do the torque analysis based on all the information given here. So yes, if you finish working by yourself, you can resume the video and we will solve it together. So we see that we said that the clockwise torque is from F, and both B and W are doing counterclockwise torque, so around A. So we put the clockwise torque on the right hand side, and it is F multiplied by R. F we don't know, R we don't know, and then it equals to the weight the weight is the point here is here. So this is the centroid, right? G go through centroid. So this part is 0.5 meters. But we notice that W is not perpendicular to the surface of the gate. So there is an angle, right? There is an angle. If here is 60 degrees C, then here is 30 degrees C. The same as here is 30 degrees C. And so here is 60 degrees C. Right? So the actual effective R regarding W should be this part. I mark it, let me mark it with a different color. It should be it's this length. And the length of this is, because here is 60 degrees C. 60 degrees, sorry. I always put C there. So it's 60 degree. So the length of this green line is 0.5 multiplied by cosine 60 degree, right? So that's W, the force, multiplied by R. Here is cosine 60 multiplied by 0.5. Plus another one is this B. This B, if you draw another triangle, let's draw it with orange. It's this triangle, right? And you can see the actual R is here, which should be 1 meter, because this part is 1 meter. So this effective R for BX is 1 meter multiplied by sine 60 degree, because here is 60 degree, right? So in this triangle, it is 1 meter multiplied by sine 60. So it becomes BFB, or I just put B here, multiplied by sine 60 degree multiplied by 1 meter. Okay, so this is the force balance. And we know the weight. We know cosine 60 degree. We know 0.5. We know B. B is also given. So I think B is given as 40 kilonewtons. And weight is given at 2 kilonewtons. And so everything on the right hand side can be calculated. So let's plug in all the numbers here. So it equals to 2000 multiplied by cosine 60 degree multiplied by 0.5 plus 40,000 multiplied by sine 60 degree multiplied by 1. I just ignore that. So the final answer you have should be around 35141 Newton multiplied by meter. That's the total force that counterbalanced the effect of the hydrostatic force multiplied by its effective radius r, right? And we say that, what is r? R is related to, so R is from the top to CP, actually. R is from A to CP, right? So you can consider it as related to both centroid CG and YCP, sorry. So then that can be solved. So in another word, you need to calculate your YCP. Okay, you need to calculate your F, you need to calculate your YCP. Let's first take a look at YCP. It seems like a low-hanging fruit. We are able to get it. So YCP is related to the rectangle we show here, and for a rectangle, its centroid is at the middle, right? For this, and we said the y-axis should always be parallel to the gate or board and then pointing upward. So at here, it should be some direction like this, right? This should be your y. I marked it as blue at here, right? So to show it here, it should be, here is your y, and then here is your x. And it's at the middle, so this part is 0.5, this part is 0.5, this part is 2, and this part is 2. And in the original settings, we have given that how to calculate IXX and IXY based on B and L. And we noticed that B, based on the drawing here, that your B should be perpendicular to Y or parallel to your X, and your L should be perpendicular to your X or parallel to your Y. So to here, it's pretty straightforward. Okay, we say B is perpendicular to Y, then this part is perpendicular to Y and parallel to X. So this side is B. So B equals 4 meters. And our L should be perpendicular to X and parallel to Y. So our L should equals 1 meter. So we solved B and L. And then we go back to here. So A equals BL, which is quite straightforward. We don't need to think about it for now. But for IXX, so IXX, it's given that IXX equals BL to the third over 12, right? So it equals to 4 multiplied by 1 to the third over 12, which equals, approximately equals to 0.33 meters to the fourth, right? That's the IXX. And what's IXY? IXY should equals to 0, right? So IXY equals 0, and A equals what? A equals B multiplied by L, which is 4 meters square, right? And we said that YCP equals to negative IXX sine theta over HCG multiplied by A, right? And this Y, we have repeatedly let you know that YCP should be smaller than 0, right? And the reason we repeat it a lot of times is YCP is should be below the centroid, because in a space that your pressure for your hydrostatic force increase with increasing depth, that's causing that your center of CP should be below the centroid of your object. So okay, and then what is the relationship between R and CP? We have shown here, right? So this part, let me change the color. Let me use maybe purple. So this part is the YCP we calculated. And this part is from the centroid to A is 0.5 meters. So we know that R equals 0.5 minus YCP, because YCP is smaller than 0, so here should be minus YCP. Let me put it here. So R equals 0.5 minus YCP. So it equals to 0.5 plus 0.333 multiplied by sine theta. We know it, right? We said it's a board, and you see how much you rotate it from horizontally. So this sine theta is 60 degree. So multiply by sine 60 degree divided by HCG, multiply by 4, where 4 is the area, right? And we notice that HCG, we don't know, which is related, but it's related to H, right? How HCG is related to H? Because for F, when we calculate F, the total force, we still need HCG, right? So F should equals PCG multiplied by A, or F should equals to PCG multiplied by A, or equals gamma HCG multiplied by A, right? So it seems for this equation, we go back to the original equation here. Okay, let's reevaluate it. So the right-hand side, we can do the calculation, and we know the exact number. And the left-hand side, both F and R are related to HCG. R, we show it here, is related to HCG too. So HCG seems to be the only unknown variable here. So theoretically, this equation is solvable. And at the same time, let's don't forget they're asking for the depth of H. So an easier way is, let's write HCG in the format of H. Then we can directly solve HCG. So what's the relationship between H and HCG? Okay, so if you H and HCG, so HCG equals to H minus 0.5 multiplied by sine theta. Why? HCG is what? HCG is here, right? Let me change the color. I'm trying to maybe let's use green and draw on this figure right now. So CG is the centroid of the board, and we know because it's a rectangle, it definitely will be at a center point here. And so this is at the middle, so this part is 1 meter multiplied by sine 60 degree. And because it's from the middle, so we know, so this part, so this distance equals to this distance. So we know it's 1 meter multiplied by sine theta divided by 2. Divided by 2 is this short distance. So the HCG equals H minus this distance. Okay, so then that's H minus 0 point, which is 1/2 multiplied by sine 60 degree. It equals to H minus 0.5 sine 60 degree. Okay, so this will makes us rewrite our we plug in rewrite this R with the new equation of HCG. So our R will equals to 0.5 plus we we calculate this part. It's calculable, right? So it's 0.0721 divided by h minus 0.5 multiplied by 0.866, and you can see that r is a only function of h, right? So it equals to 0.5 plus 0.0721 divided by h minus 0.433. Then we have our f equals to, we said at the very beginning, it equals PCG multiplied by A. It equals to rho G HCG multiplied by A, right? So it equals to 1000 multiplied by h minus 0.433, which is the same here, multiplied by 4, multiplied by 9.8, and it is 3. We calculate all these variables, all these constant here. That's 39200 multiplied by h minus 0.433, right? And f multiplied by r. We also notice that f is the only function of h right now, and f multiplied by r is the value we originally know at the very beginning. So f multiplied by r equals 39200 h minus 0.433 multiplied by 0.5 plus 0.0721 over h minus 0.433, and it equals 35141. That's what we get at the very beginning, where I showed you from the torque balance. So to solve this in Wolfram alpha, you get your h equals 2.08 meters. It's a long procedure, and right now I want to do a walkthrough from very beginning. We actually can divide it into 2 parts or 3 parts. So the first part is try to get, let me change the color. So this is the torque analysis till here. So you get that your F multiplied by R equals a fixed value. So that's based on the weight and also the force at the B to stop the gate. So based on that balance, we know this value, right? But we don't know F or R because H is unknown. So what we do next is we first try to find YCP so we can find R. So from here to here is YCP to R, right? You have F and R right now is you try to use all the conditions and you can have to have your R rewritten and try to relate it to H, R as a function of H. Then what we did is it's keep going to here, and the next thing what we did is we try to correlate F. We try to find the relationship between F and H. So F is related to HCG again, and HCG is kind of part of H. So you find F right now is only a function of H. And then you plug in, at the final stage, you plug in everything back to the original equation, because then you find that's a equation with only R as a with only H as a variable, H here and H here as a variable. Then you can solve your H equals 2.08 meters. So overall, it's a little bit more complicated because of 2 things. So the first thing is, okay, torque analysis is included. Then you need to know the effect of the force, whether they let the gate to rotate clockwise or counterclockwise. So that's the first thing, torque analysis. The second thing is, for this specific question, the plan view of the board is not given. You need to imagine how the board was placed and how the board is look like to draw it, and then to check what is B and L based on this, based on the shape of the board and the equations given. So that is about this problem. So this is the level of what equations will be like in the second exam. So take a good look at this problem and try to figure out what's the meaning of each step by yourself. Okay, thank you.